Getting set up, getting set up, getting set up. There, come on. Okay. So, hello everybody. Sorry I can't get my good camera working. I have to reboot my dang computer once in a while because of the stupid USB on the stupid Macintosh that if I plug the same camera into a different port, OBS doesn't work, or whatever. But whatever, sorry, got the crappy up the nose view. So let's talk about what I'm doing. I'm working on Tsugi, okay? And I'm doing analytics because next week, the imsglobal.org meeting, imsglobal.org meeting is next week in Ann Arbor, and visitor parking. So you could, so the hackathon, somewhere there's a hackathon, registration for the hackathon. So I go to some of these things and sit in the back and code, but mostly I go to this hackathon on Thursday and Friday, and I'd encourage you to like get in a plane if you're working with Tsugi or Sakai or anything. Get in a plane and come here on Thursday and Friday because we're going to have some fun in the hackathon. It's a great room. Oh man, I would stay downtown. I wouldn't stay there. But we got a bus that goes right to downtown. It's sweet as hell. Hella sweet, right? Hella sweet. Steal from Lemons 24, guys. And I'm going to be down, staying in a hotel. We're going to be partying. I think Wednesday night we're going to do karaoke. So if you get there Wednesday night, let me know. So I'd say come on down, especially if you're into Tsugi or open source or learning stuff. And so I am going to be trying to do analytics in Tsugi. And I'm actually, first, I'm not really going to add the caliper or XAPI stuff to Tsugi. What I'm going to do is I am building right this minute my own code that I want to make an analytics that works in a, so the best way to think about analytics, let's see, open analytics Apereo. Let's see if we've got a picture here that we can, if we've got a picture here we can look at and make some sense of this. Come on, baby, give me a picture. I just want a picture. Yeah, okay, there's a picture. So, okay, so what do we got? Learning to choose, student success plan. So here's like a tool, a Tsugi tool, right? And this is going to send events to this learning record store, right? And then this learning record store is going to be, well, actually, no, that's not it. Where are we? Oh, whatever. So, whatever. The idea is there's this thing called learning record store, and every event that's going to happen, like a click or whatever, is going to get sent to this learning record store. But I also want to build I want to build my own analytics viewer. And I had a student of mine, Clara Nice, GitHub. We built a simple YouTube watcher. A YouTube watcher somewhere in my repository video. And so this was a couple years ago. She did an independent study with me, and this Clara, she built this code, and we came up with some. We used it to build a cool analytics that, was a prototype for what I'm building right now. And the idea is that I want. So if you look at this stuff right here, these learning record stores use Mongo and Redshift and all kinds of stuff because they're trying to record too much information. They record all the information. They lose nothing because they're going to do offline analysis with giant Redshifts or Hadoop or something like that. That's fine. That is actually not what I'm interested in. I'm not interested in big data. I'm interested in transactional systems. I'm interested in high performance. I'm interested in things that happen in a quarter of a second. So right now what I am building is I am building for Tsugi a little event API. Okay? And I am doing this event API, and the idea is I'm trying to come up with a very dense way to represent these events. So what this is this is just what I call it's a serialized version that basically says it's a histogram. So there's 900 second buckets starting at this time times 900, and then these are the buckets. These are the offsets. 0 is this one right at that time. There was 802 clicks. I'm unit testing right now. At this 15 second within it's 900 seconds, which is 15 minutes. The next 15-minute bucket has 900 entries. The next 15-minute bucket has whatever. And then there is a gap. 96 900-second periods later, there's a bucket. So what this is this is a variable scale and a variable histogram. So the idea is you're doing histogram, and the whole idea is to create precisely as long amount of data, because you know it's a time series, you know that there's going to be ups and downs in it, but I'm going to maximize this to be 1K of data. And so right now I'm just doing this stuff, and what I'm going to do right now, just in case you want to follow along, is I'm going to check what I'm doing in, right? And I've been working on this for a couple hours already, and I'm going to be working on this for hours over the weekend, but I just figured I'd share with you some of the stuff I'm working on as I'm working, so you can kind of see how I approached it. And if you go into the docs README, you can see this is the research that I've done about compression, serialization, and whether or not I probably have spent a week thinking about this, writing myself notes on little pieces of paper, trying to find out the best way to compress this. Because what I want is I want to effectively order one operation for class views and order one operation for individual views, so that the amount of data is order the number of students in class, but not squared and not growing based on the number of clicks. This has got to be fixed on number of clicks, but it's kind of a multiple histogram where data can be lost, and we're going to allow data to be lost in this notion that I'm going to store the best histogram I can with the most detail in 1K of characters. Okay. And so the way this code, so I'll check this in. I'll check all this in right now. Git status, because I'm only working right now in Tsugi PHP. Normally I'm working in a UI, but this has no UI right now. So I love working in the unit tests. Git commit -a, progress, git push. So you can kind of see where I'm at in GitHub, in my GitHub, not Clara's GitHub, my GitHub, and my repositories, Python. No, actually no, this is in Tsugi's GitHub. Tsugi project. Not mine, that was Clara's. Okay, so if you're looking here, and that last commit that I just did, this was a bunch of changes. And so I started, you can sort of start to look at all the things that I did. You could see the first thing I was doing was committing research. And then I kind of committed some little bits and pieces, a class, and a little test code, a little test harness. I built a little serialization utility code that makes these pretty little key value serialization, because I know that these are integers. If I run the PHP unit test, well, up here, I know these are integers, and I know they're often small integers, and so I wanted a very special compression for PHP integer arrays, and so I built that. That's this uArray integer serialized code that I wrote that takes and expecting small integers, small to medium-sized integers, and compresses them in a super dense way into characters. Well, actually, what I was doing is I kept thinking I was going to do this in binary, and I got this doubling and scaling and all this stuff, and I'm like, oh crap, why would I do that? Why would I do that when I can use GZ on press? And that's where I'm at right now. So if we look at the code right now, let's look at that. And so this is all unit test code. And so what I'm doing is I'm running unit tests, and then I'm checking the outputs. And so I've made really good progress. This is really awesome. So what we're doing here is we're testing. I should probably call this guy clicking. Test clicking. So we got a unit test. We have starting time. We're going to create an entry. This is either for a course or for a user. And click is the method that says somebody clicked it at this time. So you just click, 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 click. And I haven't deserialized it yet, but the idea is that you pull this data out, you deserialize it, you record the click, you reserialize it, and put it back in the database. So it's not quite an update. It's going to actually require transaction, but it'll be a really tiny, short-lived transaction. Like start transaction, read, mess with, serialize, store, end transaction. So by the time I'm all done with this, when I've got a database behind this thing, this will be the first transaction that I've actually done in Tsugi. So okay. So I record a quick click. A serialize basically takes it says take this click, and so this click basically says my scale, my bucket width basically is 900 seconds, and this is the offset to the first bucket, which is the time in seconds since 1970 except divided by 900. Okay, so that's the time, that's the number of buckets we're at, given that buckets are 900 seconds wide, 15 minutes. So this will be 15 minutes, and then if it needs to, it turns it to 30 minutes. You'll see that in a second. And 0 equals 1, that means bucket 0 offset of this time is 1. And this is the real time that it happened. I mean, I'm faking the timeout, right? Now it's lost the fact that this is 99 because it actually sort of has, it's moduloing things so that they're all in a bucket, right? So, okay, so here we go. And so, so then what I do is I pretend that I got 2 months of clicks, first 3 months of clicks, 3 days of each month, and then the first 200 seconds is like click, 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 click. And I am pretending to hit the click button. So I'm faking a bunch of events, and then I'm kind of trying to pull my data out and see how my serialization is working. And so the buckets, these are just the buckets being serialized. So it's probably easier to look at this. So I'm telling it. So this is the actual serialization that I will pull this out and stick it in a database, which is in a varchar field, varchar. No, I'll probably make it var binary because I don't want a character set associated with this. I need var binary because I'm going to be compressing this field too. So this will be a var binary. But for now, it's a varchar because we're not really compressing yet. Okay, so now what we're going to do is, so when you no, that's not the right one. This is the right one. So this basically is serialized the entire thingy in that, you know, it's a 900 wide bucket. This is its starting time, and these are the bucket offsets and bucket values. So this one's quite a long time. So this is 5954 times 900 seconds after that. And so then what I do is I have this rescaler, which says, look, we gotta change the buckets. And so you can see that these two buckets, the 802 and the 900, got converted into a longer bucket. Actually, it's easier down. Let's see down here. So we go from a 900 wide bucket to an 1800 wide bucket, and a starting. So this starting is based on scale. So this is half. This is twice, this is half, and now you can see that this 802 and 900 have been combined into the 1702. And you see a similar kind of thing where you're seeing buckets being collapsed, because I said, you know, I only want, I want a smaller string. So you're going to have to collapse me the buckets, because I'm, you know, so if the string is too large, and so the idea is that the size is the size of the field that I want to store in the database, and I say, look, you got this data, give it to me this big, okay? So this I'm saying I want it 3/4 smaller than what you just gave it to me, and so it does that. And then I said, I want it half as big as what you first gave it to me, and then it like has to go up to, that's a bucket an hour. 3600 is a bucket an hour. That now is the number of hours to the first bucket. These are hour offsets, 24 hours. And you can see how this compression works quite nicely, right? And so what I do is I'm sacrificing detail as scale expands, okay? So, but that's not all. That's not where I'm at right now. So I want to make it, so there's this variable called compress. And this is where I'm at right now. And that is I want to make it, so here's the idea, right? In serialization, I'm told how big I want it, and I serialize the current buckets, and I concatenate the scale and the starting time. I'm inside of an object here, and if the length of what I am about to send back is short enough, I just give it back. I mean, I don't need to lose any detail. I'm about to work on compression now, So now what we do is, actually, no, I don't need these two variables. So the first thing I want to do is double the scale or quadruple the scale. Let's just make sure I didn't break anything by PHP Unity. Yep. Okay, that's nice. So just keep running it. So I'm either going to try to scale it by double or quadruple, and that was this. I'm just building this as I'm building the unit test. So basically, this is 3/4 of this length. This is less than half, and that's forcing it to do the double scale and the quadruple scale. The serialize is actually not changing the data, because you have this data, and I'm saying serialize it this way, serialize it that way, and then I'll decide in other code which one of those things I want to store. Right now I'm testing to make sure that this code can leap through all of the things I want to do. Now, here's the thing. I'm going to do my compression. So I'm going to actually say the first strategy. The first strategy is I'm going to actually use compression, because this is a string, and this is a string that compresses really well, because it's numbers, colon, and equal sign and comma, and so zlib, run length, it makes this little table. Now the length has to be probably above 20 characters, because the compression builds a table at the front and a length at the front and a couple other things, right? So let's do this. Strategy 1. Compress if we are allowed. And I like strategy 1. If I can compress it, I'll have to uncompress it when I come out, and I'll figure out that when I'm deserializing. If I can compress it, I'm losing no detail, right? I'd rather keep the scale low and have good detail. I should put strategy 3 here. Strategy 3, pitch data. To do. So I'm going to have to, in strategy 3, you're going to see me throwing away data in the beginning to make it shorter. And so, but I'm going to, first I'll double up the scale as long as, I should probably say this, I think if $this scale is less than, well, I'll just make something up here. We'll make this 6 hours. 6 times 60. 60. Buckets. So what I'm going to basically do here is I want it to fall through. I mean, at some point, I maybe make that 24 hours. Because then if you're going a long way, then it's a day. And the problem will become, if you use something and then go months at a time, you might be able to do it. But we'll see what happens here. Because I do want to. Never mind. So fun, dynamic. Writing dynamically adjusting code is so fun, but you got to test the crap out of it because you're going to lose data. But strategy number 1 is compressing, since it is lossless. Okay, so compress. And we have to, function exists, we have to have compression. So this is one of the things in PHP. Function exists. GZ compress and function exists GZ uncompress. Feeling good about that. So, can you use uncompressed in Java? And just as I write this code, I'm thinking, how does it work? How do we do it in Python? Come on, Stack Overflow. Well, zlib, so that's nice. Okay, I'm happy about that. Python. What else do I care about? Java, Python. Oh no. I think we're good. Because I wanted to do it in server. You can do compress in MySQL. Compress function. Kind of works the same way. But I don't want to do that. Okay, I want to do it here because I want to be able to make decisions. I could change it later if I really have to. So if I'm allowed to compress and those two functions exist, then all I want to do is I'm going to say compressed equals GZ compress This is, thank heaven there's nice libraries to do this for me. Then I just asked this question. If after I got done compressing, is it good? Cha-cha-cha, right? Okay. So now I'm going to grab some code. I'm going to say $compress equals 2. So now I'm switching to my true. I'm switching to my unit tests. So I'm doing all my development, all my testing in unit tests. And this way I just am spewing unit tests as I go, which is totally cool. So now I'm going to do this, make this smaller, 75%. So it's not going to fit, but now I can Y to Y. So serialization 4, and I am going to echo into hex serialization 4. Echo \n, and that is going to fail. No, that's not fair. What did I do wrong? Oh, serialization 4. No. Oh, that's nice. So now I can do this. That's what serialization 4 is. And that's been hexed. And it did it! Dang, that was easy. Okay. That's gonna do that. And I'm going to say sticks. Okay, so I'm going to then say, oops. Serialization 4. And is less than or equal to $, smaller. Meaning what I got, I'm just asserting I'm going to do that. Just whatever I asked, and just add another sort of more aggressive unit test that says, look, I want these serializations when they come back. Don't be giving me stuff that's bigger than what I asked. So that's going to do that. It's not going to change my output, but it'll be sort of a more. Okay, so that print statement can come out. Just comment it out for now. That's nice. So the interesting thing here is I need to do this. I'm going to actually try to compress the scaled guys too now. Oh yeah. See if I can force it to scale and compress. And so this So what I'm saying here is if I would rather go at scale 2 and compress. So if I'm scale 2 and I'm not compressed here, but if I can compress and I'm at scale 2, if I've doubled the scale, you know, doubled the width of the buckets, I don't want to quadruple the width of the buckets if compression would get me under my maximum length, and I'm allowed to compress. So that's pretty dang sweet. And I love to run the unit tests again. That's what's fun about unit tests. You know, that's what's fun about unit tests. It's testing everything, not just the one line of code I changed. Okay, so that's nice. I think I can cause that code to run by well, let's just try this one. Let's see if I... Okay, so let's see if when I just go to... If I just go to half size... So we got a problem that I'm getting a little small here. So this is going to be serialization 5. Print this one out. Move that one. So let's see if that will actually, and when I went to 0.5 it went to scale 4, but if I can sort of trick it to do scale 2 and compress, which means it's going to compress that. It's going to be hard, we'll see. I might have to tweak with this number a bit to get it to run that code. I'm going to do this. Like the Muppets, to see if I ran that code. Yay! Look at that. Bada boom, bop. Look at that. I think this is what my unit test. So it hit that code, which was what I was trying to do. I mean, that it's tricky enough to make it hit that code. Yep, and that's smaller. Look at that. That's the compressed version of it. Chinkity chinkity. Yep. Okay. So that's going to go like this, and there's no, I don't need that print statement anymore. And it's working, and I don't need the yay anymore. So now I'm kind of back to pretty much silent happiness. Yep. Okay, that's cool as crap. That is just cool as crap. Okay. I guess I should print something out. Which one was this? Did I compress this as let's see which factor got me down to it. If it's factor 4, it hardly counts. Yeah, factor 2. That's kind of what I wanted it to do. Yeah, so it's factor 2, meaning it's reduced it by or reduced the number of buckets by 2, or increased the bucket width by 2, and post compression it got me what I wanted. And so it didn't. In this case right here, without compression, it had to go all the way down to compression 4. It had to go down to bucket width scale factor 4, hour wide bucket, right? Instead of a 15-minute bucket, right? 15-minute bucket, 30-minute bucket. Now to get half the size, I had to use a hour bucket. Now to get half the size, I really still haven't. The uncompressed data here is really this data, right? And I got it on. So if I'm allowing compression, then that's a better way to put this data out. That's why I want to compress in the server, not in the database, because I want to be able to run this code and intelligently decide it. The other thing that's kind of interesting here is if you think about a scalable application, it's much easier to scale the front end, the code running in the PHP part, than it is to scale the database. And so I'm happy to pull some of this compute and grind through this to figure out the best compression, rather than trying to make the data hit the database, check to see if that. I just keep the database out of this. Rather tricky, because I'm not done yet, right? So, okay, so let's put in some comments here. Okay, give this a try with compression. Okay. Okay, so this is an array, right? Those are the numbers. So now I'm down to this situation where, so let's blow this up. it pitch data. $compress false. So we're not going to let it compress anymore. And I'm going to say, you know what? 0.25. I want this super small. I want this really tiny. And now I am expecting that it's going to die right there, because the pitching data, shifting off data off of the early part is the last resort. Let's run it, so it should die. Bad. I should make my die message a little bit, whatever. So that means it fell through all of my first two strategies because I'm trying to compress it so much. Okay, so now what I'm going to do is I'm going to say new buckets equals buckets. I'm not going to change the scale in this one. I've already tried to change the scale. I tried to compress it. I tried to change the scale up to 4 times the scale, and that did not make me happy. I'm not going to go 1,000 times the scale. As a matter of fact, what's probably going on is it's just a long time ago, and so the scale's not helping, because I had sort of a month ago I had very busy activity, and then today, a month later, I had no activity and then some activity here. So we're just going to start throwing stuff away. So we say CW new start. New start. And array pop. Is array pop returns the last array. Or is it array shift? Array shift. Shifts the first value of the array off and returns it by 1 element, moving it down. Well, what do I get back if it's a key value array? No. What happens? Array K shift. There's array K shift. Oh, here we go. Okay. That's what I'm doing, boys and girls. I'm filing array shift. Okay, so now some mic testing. Some Claris code. Okay, so let me do this. Source util php. This is my little utility class that just puts in useful crap. And I want to use the class loader. Fix this. Arr. That's going to be what I'm going to use. Oh, I guess I got to write the code. Public static function. This just keeps me out of, by putting this all this into this util class that I've got. This keeps me out of the namespace. And this will be a little costly, but I just don't care because these things are going to be small. There's going to be less than, you know, probably 30 or 40 of these things. And I just consider like CPU cheap. I better put that in as 100% dollar array. So we get that first key. I don't quite understand what that does. What does list? List sub k. No, I don't get it, but I'll write a unit test that will get it. all the unit tests. Ah. Entry test failed. That's okay. Wait. E. It's E. Oh. Array. Oh. New test. There's an ear. Nice baby. So my entry, my code here is still failing, but this is good. So we don't need that. So we have made that. So that'll check all of the unit tests. Nice baby. So we've got back just to running our unit test. I do like PHP unit tests. Okay, so now we're going to go back to dying here. Strategy 3, pitch data. Okay, so what we're going to do is we're going to say, it's going to be crazy. While count of our new buckets is greater than 1. I don't know, look out. Count of new buckets is greater than 1. Actually, do I even want that first entry? I still think that was not a bad bit of code. Array shift. Array shift. Oh, I like what this does. No, I don't like that. I don't want the keys renumbered. Well, no, I do want, or will I want the keys renumbered? Oh, this is going to be ugly. Oh, this is going to be ugly. Actually, I know what I need. I need a loop here. Yeah, because I need to reconstruct this array. So okay, so what I really want to do here small buckets. First equals false. Okay. For each, I just got to write this code. New buckets as $k maps to $v. Oh, come on. Did we just die? My laptop just die? Oh, is the string's okay? Okay, so should the first offset always be 0? So the first offset always should be 0. The second, let's make this be 4. So the first offset should be 0. So it's going to be 0 equals 42, 17 equals 204. So I want the second one to become 0. Well, okay, so I'm going to say just like $position equals 0. So okay, so if we are in position 0, we're simply skipping it. So well, this is going to be some chatty stuff. Okay. So we're going to go past, we're just going to go past the 0th position. And go past the 1st position, and then we're going to, so if we have a start here, equals 1, 2, 3, 4, that's the initial. Offset is the 17. So what we want to do is we want to subtract 17 from all these entries. So we got to just skip the first one because that's the one we're throwing away. Then we got to capture the offset value. So I'm going to say offset equals false. Let's just do this. $pos plus plus. Position equals 1. Continue. First entry. Okay, so now if offset, actually I'm supposed to be using null for these. If offset $offset equals $k, the key, 17. So now new key, new offset equal the old offset minus the first offset. So I'm going to call this guy first offset. I find that when I'm writing these subtle algorithms that are really thoughtful, okay, so mnemonic variables tend to be more important, the more intricate your algorithms tend to be. So now I've got the new offset. So I'm going to have like 20 equals 177. So this one's going to go away. This is going to become 0, and this is going to become 3. Right? So that's new offset. That's new offset right there. 17 to 20. That's new offset. Oh. So I'm going to stop and start the streaming because. Okay, so I'm restarting streaming. I'm almost done with what I want to do. It's been an hour. It's amazing how fast time flies when you're doing like intricate algorithms that really matter. It's live, but it's not receiving enough video. Oh, now it's okay. So now it's okay. So here we go. Okay. Screen. Okay, so like I was saying, it's very important to give these things new names. So the fewer buckets, so now I'm going to say $fewer buckets is sub new offset equal, so that's really kind of old buckets. Old buckets are. Fewer buckets equals old buckets. Old offset. Yeah, it's nice when you can write lines like that. It makes sense. So when it's all said and done, basically, fewer buckets should have everything but the first one, and then all these will be adjusted downward by that number right there. So there should be one less. So let me just do this. Okay, so old buckets. Now what I'm going to do, so I've got this fewer buckets. I did all this to shift it by 1. And now what I'm going to do is do this. I might have to turn this into a function. I'm almost done with this guy. A lot of logic here. So. I gotta fix new scale. Start. New start. So our new start minus equals $new start minus $offset. Let's drop that down. Drop that down. And then going to serialize it. So this is just we haven't changed scale here. And then the new start, and then this is going to be fewer buckets. So if we got below it that way, if we're allowed to compress, and we got rid of 1. Done. And then okay, this will be an infinite loop unless I say $old buckets equal $fewer buckets. That sure better go down. I better say this. if count of old buckets minus 1 is not equal to $ fewer buckets. Count of $ fewer buckets because if it's not getting smaller, throw. Whoa. Oh no, that's in. Where's that throw at? Just need to where I last time I threw it. Where did I throw it? There we go. Bang. I don't know if I should, but I should do that. Okay. What happens here? Let's just run it. It seems to have done something. Okay, so. Oh, undefined variable. Oh. First offset. So that should be a plus. We're advancing forward in time. No, no. Actually, no, this is going to be serialization 5. Oh, something happened. So I want to compare that with serialization 3. Serialization 3 is when I so serialization 2, and I'll look at serialization 2 and serialization 3. This is some real algorithmy stuff. And I'm going to have to quit pretty soon because my brain is kind of like it much. Okay, so Oh, I need to look at serialization 1 because I didn't change scale. So serialization 1 is serialization 1 is the 15-minute scale, because now what I'm doing is I'm finally forcing it. Oops. Oh, this could be so cool. Smash. 38. Look at that. Oh, but why is that 5385? That's not being subtracted. Oh, yeah, it's because the offset. No. So that went up. And it went up too much. And this is supposed to be 0 equals something. So these are, I think that's that. 900, 299, 801, 900, 299. So it chopped and chopped and chopped, but it didn't end up with this right. So what this should be is this number should be 5857, higher than that number, and it's way much higher. And this isn't 0. So let's just do this. Let's just run one algorithm. Let's run one loop through so that the first time we've shifted, so I can see what one increment does. Oh, that looks good. So, but how can that number, that's really very wrong. But the interesting thing is this became 0 equals 900, and it's 5953, subtracts this number, so that's looking really, that's interesting. So that's looking really good. But this is totally wrong. The number is totally wrong because that should just be 1669504. New start. Oh, not new offset. First offset. This is why I named them, because it's that offset of the first one. Okay, we'll run it again. Make it through one time through the loop. There we go. That's pretty. So it's 904. 904. Then shift it. I like it. I like it a lot. Okay, so what I'm going to do here is, instead of this true guy, I am just going to simply echo red bell. Actually, I'm going to say position. No. Position. It's okay. I'll know where I'm at. Okay, so I'll print all those out. Blink. 51, 51, 151. Okay. 506, 507, 508, 509. Completely wrong. So in this case, first offset needs to be 93. That is the bummer of it. Oh, good. It's a danger when you're playing with integers, isn't it? But a truth still first offset at 1. It's right. First offset at 1. Oh, first offset is 94. Okay. So first offset seems to be working because it stays 0. What's going on? It's like working. This is looking good. Oh, it started working because of position equals 2. Yeah. I've changed something and it looks like it's working. So now let's comment these guys out. And now let's just run beginning to end. Okay, so this is what we got. Oh, it looks pretty damn good. Okay, so 801 guy is this guy. So that this should be plus this number right here. 636. Yes! We are shifting. We are happy shifters. Happy little shifters. Okay, so that's nice. I think it's time to go out and work in the garden. So what we can do here is we can go put that into our okay, so This is going to be fun. Because the next thing I'm going to write is an uncompressed function. And then I'm going to unit test the crap out of the compression bits. Okay. So now what we're going to do is we're going to allow it to compress. Yep. So it compressed. Chose to compress. We're going to have to write some decompression code to figure out if we liked it. But we can believe that that's probably doing what it's supposed to be. Okay. I like it. I like it. Okay. Just put a nice little error, happy little error log in there. It's just going to run for now. Won't die. Peachy fine. Okay, you know what I'm going to do right now? I am going to commit it. Git status. Git commit -a. More progress. Hit push. So I'm going to build an uncompress. So the interesting thing about this uncompress so here's the thing. Public function I'm going to make it so you can uncompress and call it multiple times. So I am going to say this. I don't think for each goes through a string. Only iterate on string characters. Yeah. Old school. Okay. So, given that the only legitimate serialized entries have 0 through 9 and colon and comma and equal sign, I don't need to uncompress it. So, if not $needed, check that out, huh? Return $text. Otherwise, return, what is that? Goes uncompress. Goes uncompress. So it is. Goes uncompress. Check that out while the waiter serves it. Ice, ice, baby. No one's watching. They might watch afterwards. Okay. So, now, well, let's just see if I got a compiler error. Let's go crazy. Now push. Run the unit test. Of course, I got a compiler error. 107. Wow. Unexpected curly rays. What? Yeah. What? Huh? Gotta go work on the outside. That does not make any sense. Unexpected curly brace on 107. That is like insane. I don't get it. Okay. Oh. Is that my problem? Oh, Jesus. Man, that's maddening. Okay, so now the fun thing about this is let's throw this all over the place. So watch this. Watch how much fun I have. So I should be able to do this. Now I think I can make this guy static. Yeah. Notice he does not use this at all. Well, I can say So it says that this is uncompressed already, so it should not double uncompress it. And that's what it does. Okay, so now, watch this. Let's go crazy. And you should be able to uncompress as many times as you want. Yeah, I know that's crazy. Something else. So now the interesting thing is so you see now I can basically uncompress these guys. Which is cool because I can see what they're supposed to look like uncompressed. Supposed to be 36. That's the 36 one. Actually, happy. Okay, so I don't think that's going to be serialization 3. That's going to be something else. Yeah, so that's going to be 30. So that's going to be Let's make it smaller. is smaller. It is indeed that much smaller, which is pretty damn sexy. You like it when your complex logic starts working as you expect it, and you just keep adding unit tests. You just like, while your brain is into it, you just add tons of unit tests. Okay, so so I made it so that if it will go no lower than 5 buckets, if I'm not mistaken, or 4 buckets. So I'm going to guess so false. Oh, I got my die in there still. Buckets is all you get. No matter how much data you ask me to throw away, I only get 4 buckets. And it's not smaller. It's bigger, so that's false. Isn't that dang sweet? That's dang sweet. What? Oh, is this the error log? I don't want that to come out on a unit test. I just won't put that there. That's tacky to have a thing come out on a unit test that worked. It's exactly what I expected. But that's okay. I'm sure they did it on purpose. I think I'm done for now. A little quarter view. That uncompressed turned out pretty good. Okay, well, I guess that's all for now. I'm going to just go out and think for a while and clear my head and do some gardening, and then I'll come back and I don't know. After I've done gardening, I'll figure out what I really want to do next. So, cheers. There's OBS. Minimized OBS. Come on back, OBS. Stop streaming.